Hello, everyone. Thanks for joining. We're going to give people a couple more minutes just to start coming in here. We'll be giving an interactive demo. So if you'd like to follow along, please create an account at tgcloud.io. This is our TigerGraph cloud platform. It's completely free. Just create an account. You'll have to verify an email. And then after that, you'll be able to follow along with our live demo. So I'll get started about 3 or 4 after, just once people have stopped trickling in. I'll put this up here too. All right, so for anyone just hopping in, this will be the TigerGraph 101 as part of our UCSD series. And if you're looking to follow along with the interactive presentation that we'll be doing, please create an account at tgcloud.io. It's completely free, and this will allow you to spin up a TigerGraph cloud solution that you can use to follow along with what we'll be doing in the demo. So I'll just give it another minute or two, and then we're going to jump right into things. All right, great. So it is time to get started. Hello, everyone. My name is Daniel Barkus. I'm a developer advocate here at TigerGraph. I've been working here for only about 2.5 months, but I've been using TigerGraph for probably close to 2 years now. Used it a lot at my previous role. Sort of came into TigerGraph with not really knowing what it was, not really knowing what graph was, but clearly it was enough to really get me to stick with it if I eventually ended up changing my career path over to something much more graph related. And hopefully by the end of this demo, it'll at least allow you to get an understanding of what graph is, how you can use it, and hopefully get you excited about graph technology as well. So just some basic housekeeping items. You will be muted, but feel free to ask questions anytime using the Q&A tab. I'll be having my eyes on that, and so will Kelly as well. So hopefully we'll be able to answer your questions as they come up. And this meeting is also being recorded, just for anyone who's wondering. I think you get a notification of that when you first log in, but figure I'd state it as well. So now that that's all there, I'm actually going to have us do one more thing before we get into the demo. So if you followed that link before for tgcloud.io and you created an account, then I'm just going to have you log into that account, and we're going to create their first TigerGraph cloud solution. So that way you can go ahead and get started with that. So you go to tgcloud.io, it'll ask you to log in. You can log in, and it'll probably take you to the dashboard page, and you'll just want to click down to My Solutions. This is where we'll actually create a graph. From there, you'll select Create Solution. For this one, we will be using we'll be using a blank one. So go ahead and select blank, and then next. For this demo, y'all can use a free tier solution. You only get one free tier solution per TigerGraph Cloud account. That's not limiting though. At any point, you can tear down that free tier solution and spin up another free one. You can only have one free one at a time though. I already have a free one set up, so I'm just going to grab a paid one for this demo, but the free one will work perfectly fine for the purpose of this demo. There's no functionality difference between free and paid versions. It's purely the amount of resources that your machine has. So there's really no limitation to selecting the free instance. Give your solution a name. This is just something easy to help you remember it. TigerGraph 101. Password. This is just the password that you'll use to log in. By default, it is TigerGraph all lowercase. I'm going to set mine to that as well. And then subdomain, this is a little bit important. So this is the actual address that you'll access your TigerGraph server from. So just make this something that you can remember. I'm just going to make mine TG101. And go ahead and click next and submit. And I already had made one called TG101. I've done this demo a few times, if you may have guessed. So we'll just throw some more numbers on there and submit. So this will take about 2 to 3 minutes for it to actually initialize and set up, which is why I wanted us to do it now. So that way I can hop into the presentation while hopefully everyone's demo spins up in the background. So today we will take a look at graph databases, how they differ from regular databases, and hopefully we will get to setting up our own in TigerGraph. We're cutting it a little close on time, but we will definitely get there. So to understand sort of what graph databases is and why they're important, we need to kind of take a look back at the way that we've been doing everything sort of beforehand with traditional relational databases. So your typical relational database is, as you may know, it's tables. So you have a table which consists of columns and rows. Each one of those columns represents a different aspect of your data. Say you're storing user information, that may be something like first name is a column, last name is a column, email address is another column. And then each row would represent one user in that table. Now, if you wanted to connect that user to other users, or if you wanted to connect them, like in this example here, you have some products, you want to relate them back to an order, who their supplier is, you have to do all these joins between the tables. So when you want to write your query, you have to join table A with table B, so that way you can get, what product was ordered from what order, and maybe the product specifications that you wanted to get out of a particular order. And it ends up creating these complex queries that can be slow to operate, just because you have to do all of this, all of these joins and all of that math sort of during query time. So it can really slow it down. So the core concept behind graph is kind of taking all of that query time joins and all of that needs to be done and sort of baking that into the nature of the database itself. So a graph database in a way is similar to a bunch of tables that are linked with joins, except instead of those joins being computed during query time, they're pre-computed when you load in the data. So now if I want to go from something like this graph example here where we have an order, I can quickly see that the product that it relates to, the customer that it relates to, and all of these connections between going from order to product or order to customer, these are just as fast as looking up a single value in a single table. So you're really able to gain that performance there by pre-computing those values and generating them as a graph structure. So that's kind of where we get into label property graphs. So TigerGraph is a label property graph, meaning that it consists of nodes and edges. So each one of these circles is a node, and each one of those lines is an edge. So those nodes are able to contain attributes. That's where our labeled property graph comes from. So those, my screen. So those attributes could be things like for a payment, a unique identifier and an amount, something like an order, a unique identifier, a quantity, potentially even the label of the type of product that was ordered, the date that the order happened at, things like that. So you can really get an idea of not just this thing points to this thing, but they have these attributes within them as well. And then the edges that we use to point between those things can also have attributes between them. For example, if we wanted to know what date our order was paid for on, we could see that from the attribute within our edge. So that's kind of cool and all, but where does this all fall into the real world? So the big advantage of graph comes from being able to take a bunch of disparate data sources and connect them. So one of the cool things about those connections between these different data sources is you don't just get the value of each one of those data sources, but as you build these connections between them, the value that you can get out of it just compounds. So just being able to look at one point of data and another point of data and get the insights from each of them separately and then compare those insights to each other, yeah, that's great and all. But being able to take those two things and really explore how they interact with each other, how the different pieces of data fit in with each other, and then gain insights on the combination of those data sets, that is significantly much more valuable than looking at each one of those things as a standalone aspect. So that is where graph comes in, is its ability to inherently connect those different pieces of data to allow you to get a full-scale view of the problem that you are dealing with instead of dealing with each chunk individually. This really shows itself in supply chain management. Supply chains are vastly complex things. You have a bunch of parts, different manufacturers, you have different things that they're going inside of, you potentially even have different models of those things that they're going in. So you have to keep track of all these different things across the whole product manufacturing pipeline. And those can be supply chain data, those can be stuff like order data, those can be things like manufacturing data. Now you're seeing these are all different data sources. So the naturally graph comes in here by allowing us to combine those to each other and get a full view of sort of that supply chain end to end and how different aspects of the business or external aspects are interfacing with it. Fraud detection, very similar thing. Obviously, looking at a record of payments or transactions or things like that, you can sort of see some areas where there may be fraud, just looking at that within sort of its own case. But once you take in additional information, okay, this person visits these websites or has these interests from Facebook or whatever, and now they're purchasing things that are completely unrelated to the things that they normally purchase and the things that they like. Has this card been stolen? You know, is this person just picking up a new hobby? So now you have the ability to really explore those types of interactions and the way that those different data sets can combine and really get more information out of them. User journeys are also a pretty common thing, looking at how someone interacts with the system. I know that we have one of our clients is a healthcare tech company. So there are so many different areas that you can interface with the healthcare system. You go to a pharmacy, you go to a walk-in clinic, you go to a doctor's office, you have a telehealth visit. All these different things are across all these different systems. So by being able to take those separate data sources, bring them together, and tie them to one central patient, now you get an idea of how that patient interacts with the healthcare system as a whole. You get a much better idea of how healthy they are and where you can help try to prompt them to live a healthier life. So that's a lot of talking. Let's get into the fun stuff. So today we'll be building out a very basic mock social media graph. So we're going to have a person, or multiple people rather, and those people will be posting and liking posts. And those posts can have hashtags. And additionally, those people can send messages between each other. So in order to set that up, we'll sort of need to define our schema. This is a very basic idea of our schema. This is how our nodes and edges will connect to each other. But to take a look at some of the data that will be in each one of those nodes, like I said, this is a label property graph. So each one of the nodes can also contain additional information. So our people will have emails, usernames, names, and a join date. Our posts have the content of the post, the data was posted, and a deleted flag. And hashtags just have their tag, and messages have a subject and body. And then these are just sort of the edges connecting them. So that's great and all, but let's get to actually creating it. So if we head back to TigerGraph Cloud, we can see now that our solution is ready. We click on it, you can get a little bit more information about it, but what you'll want to click on is this applications button here, and then select Graph Studio. This will bring up the Graph Studio interface where we can actually explore our graph. So you'll be prompted to log in there. Mine just automatically logs me in because I have the password saved, but you'll get greeted with this view. So what we can do is go to Design Schema, and you'll see that our schema is currently blank. So we need to create our schema. So if you click this little plus, it will add in a vertex type. If you'll remember, we had our first vertex was person. And then here we have the primary ID. So every vertex of any type needs a unique identifier. So each one of our people will need a unique identifier to say who they are. Each one of those messages that we had or those posts will also need a unique identifier. So we just have to specify what that's called and what it is here. For our person, we're going to be using their name because we have a limited data set. You know, in the real world, obviously, you would want some sort of actual unique identifier. People can have the same name. But for this demo, we'll just be using that. And then additionally, there's this as attribute feature here. So normally the primary ID of a vertex is not accessible. So when you want to query it, you can't get that primary ID back out of it. So by checking as an attribute, it basically duplicates that primary ID as an attribute on your vertex. That way, when you query that vertex, you can extract the primary ID out of it. Then in order to add attributes, you can just do that by clicking the little plus icon here, adding in the attribute that you want and selecting its data type. Most of ours are going to be strings for this, so we're just going to do that. And additionally, you can set a default value. By default, there are already predefined default values for each data type, and you can view those in the TigerGraph documentation. But if you wanted to override that for some reason, you could do so with default value. So we had name, username, email, and join date. Username, email, join date, string, and date time. And we can click OK, and that'll create our person. So I'll just do that again for posts. And our posts had their content posted on and their deleted flag. So content was a string, posted on is a date time, and deleted is a Boolean. Right, there it is. So now something important to note is that while I am doing all of this through this visual interface, everything that I'm doing by clicking and dragging and clicking on things in here can be done through code. So we actually have a bunch of great plugins that allow you to integrate with TigerGraph from Python, JavaScript, or really whatever language you prefer. And you can do all of this programmatically through lines of code as well. So that can make this a repeatable and deployable process if you're trying to set up some sort of solution that can automatically create a graph or upsert data for you. Person, post, hashtag, and message. So message, and our message has a body and a subject. And lastly, we have a hashtag. So there's all of our vertices. So these will contain, each one of these will represent a person, a post, a message, or a hashtag. Now let's go ahead and create the edges, talking about how they relate to each other. So we'll start with our person, and we'll create an edge to the post or person posted. So we'll call this posted. Now the thing to note here is this button called directed. So this one is a directed edge. So the important thing to note is that you can have directed edges and undirected edges. And this really helps you figure out this is representative of the actions that's sort of taken. So when deciding whether an edge is directed or not, I like to look at the action that the edge is representing. So in this example, our edge represents posting a message. So in this example, a person posts a message. So therefore it's directionality. The person is doing that action. There's some sort of directionality to that action. You know, a post can't post a person. So going reverse from that doesn't really make any sense. So therefore this is a directed edge. The important thing though about directed edges is when it comes to query time and you want to traverse these edges, you can only traverse a directed edge in its actual direction. So because of that, we have the option to create a reverse edge here. So basically what this does is it just creates an edge that goes along also between person and posts, but directionally that edge goes from posts to person. So there's some reasons why you'd want to pick a directed over an undirected edge. I'm not going to get too into those right now because it's really just supposed to be a high-level overview of TigerGraph and how to use the tool, but you can learn a lot of that through our documentation as well. So posted from post to person, and then we have an attribute of post time. So we can add attributes to our edges once again the same way as we did before, and that post time is a date time. Now, one thing you'll notice here is that these edges do not need a unique ID like our vertices do. They don't have any primary ID here, and that's because the primary ID for the edge is a concatenation of the primary ID of the source vertex and the target vertex. So it's always going to be unique on its own. Now let's create one for liking a post. So a person liked a post. Once again, that is directional because post can't like a person. And once again, we have another date time just specifying when this actually happened. There we go. Oops, I put that the wrong way. And at any time you can edit these by clicking on edit, and I can go from person to posts instead of the wrong way, which I made it before. It's important to note that you could point an edge back to its same source vertex. So for example, here, person could point to person. This would be useful if you had something like you were representing friends, like we're friends on social media. Person would be friend with another person, so there's nothing wrong with that. And also important to note here is that that would be a good example of an undirected edge because friendship is kind of mutual. So that friendship goes both ways, therefore it's not fully directed unless you're in some sort of manipulative friendship, but I recommend you probably don't do that. Anyway, so our messages, we're both going to be able to send and receive messages. So our messages will go from person to message, and then we'll also have another edge that goes from message to person. So this would be sent message. This is directed because the act of sending a directed message is directional. And then for these, we're also going to hang on to sent message, the person that was sending the message and the date time that it was sent at. We have your user and at date string and date time. And then similarly, we'll do the same thing for received message. And that has the from user, send date, and open date. And we can just set our values for those. So the nice thing about the schema is this is really only something that you have to do once. Once you've defined your schema, you can go ahead and start working with your graph once you have the data in it. So sent message, received message, and then post, our last edge here will be has tag. It's directed, and there are no attributes there. So this is our basic schema. You can see it is hopefully representative of what was shown here. Sent message, and then message in received message, and then posted and liked and has tags. So that all looks good, although our received message edge is going the wrong way from message to person. There we go. So now that our schema has been defined, we can go ahead and click this little arrow here to publish the schema. It'll take just a second. There we go. Schema is updated. So an important thing to note here is that within any TigerGraph cloud solution or any TigerGraph solution, regardless, you can have multiple graphs. So we've created the schema here. This is under our global schema. If you look here, if we see global view, if I click on that, we can see this option to now create a graph. So technically we have not created a graph, we've just created the schema. So if I click graph, then that gives me the option to select which points from our schema I'd like to include, and we'd like to include all of them. And I'll just call this, I believe the default name is my graph, but you could give yours something more interesting should you want to. Clicking the create button will take about a minute for it to actually spin up the graph. But once it does that, then we can start mapping in our data. And I actually need to give you a link for that data. I realized I forgot to do that. 1 second, please. So here's a link for the sample data that we will be using during this demo. You could go ahead and clone that repo or just download as a zip file. You will get all of the data that you need. I'm just going to drop in my downloads. And then from there, you can open that up. And that will just give you a bunch of CSV files. So what we'll need to do now is actually map that data to our graph. So we can do that by going back to our graph here, which we can see has finished creating. So we're now in my graph instead of global view. So let's go to map data to graph, and this will allow us to actually connect that data. So if we click this add data file button here, it'll bring up a little upload prompt where we can then select any files from our computer. So here's all of our data files. We'll click open. This will upload them. And then we can also click through these and sort of explore these files. So an important thing to note here is that we have some options that we can select for our file. So for example, this file has a header. So you can see that it's pulling in the header right now as the first row. But if I click this has header checkbox, then now we actually have our proper header names in here and our rows of data. This messages field, you can see it's all messed up. Once again, it has a header, but that's not going to fix our problem. We do have some enclosing characters around it though. So by selecting quotes, we can see that this puts us into a much better place with our data. And we'll just do that the same with the rest of our data. So it's just important to know the data that you're loading in, what it looks like, and anything that you might need to do with that. So now that I have this, we can go ahead and start mapping data. So I'll add our users file in. This just has information about our users. And then if I click these two crossed arrows right here, map to vertex or edge, what this does is it links each one of those columns from our data file. And here we can see the ID and attributes of that vertex that I clicked on. So for here, our ID is our primary ID, email is our email, and we'll see here that these names more or less line up with the names here. So while I could go through and manually click through on each one of those to set it up, there's this handy auto mapping button that you can click, and if those names map up, then it'll just join everything together for you. So I've mapped that users to people. Now let's go ahead and just map the rest of our data files. So posts, you'd think that normally you would attach this to posts, and you would. So we'll attach post to post. But what that doesn't do is create the linkage between our posts and the people who are actually posting them. So give me 1 second to show that right. So we are creating discrete posts and we're creating discrete people right now, but we have no linkage between them. So in order to do that, I need to create a mapping between posts and this edge here, posted. And what that allows me to do is pick which field here represents our source person. So this is, or our source vertex. So for example, this is the ID of the post. So we want that to link to the ID of the post. And then here we have a section by user. So this is the user who made the post. So we want to link that user to this post. And then we also have this edge attribute of the time that it was posted on. So we'll just link our posted date to that attribute. And now when we load in our posts.csv file, it will create our posts and it will also create the edges that link our posts to our person. So one of the kind of gotchas here, which is kind of cool in a way, is if you have something, you don't necessarily need to link a file to a vertex for it to be created. So edges, if you'll recall, they have their the IDs of the vertex that they go from and to. You can't have an edge that doesn't have a source or a destination. So if I make a mapping like this, where I'm telling it to create an edge, and one of the vertices doesn't exist that it's going to, then that vertice will simply be created using the information that it has from this post. So for example, we are linking here posts, so their post ID to their hashtag. So if I were to click one of these hashtags and link that in, I do not need to then tie posts to hashtag, because the only thing within our hashtag is that primary ID. So the hashtag will be created with this primary ID from this data field. And additionally, one more little thing is you'll see that I have, my data is not structured the best way. So we can see that these hashtags are broken out into 4 different things. So in order to map each one of those hashtags, I just need to create a mapping for each one of those data fields. And I'll just go ahead and do that really quickly. And then we can get through with mapping the rest of our data. You'll also see here how I linked in a blank hashtag. So in the real world, if there was no data in that field, then it simply would not be created. Or if it was a field like this, it will be created as a blank string, because like I said before, we need something to point our edge at. So we are going to end up with a hashtag, which is a blank string, which has any of our blank hashtag fields attached to it. And that's fine for this use case. That's something that we can just delete afterwards, or we can just ignore in our queries. But it is just worth noting that those types of things do happen when you're loading in data like that. So let's go ahead and add our messages. Our messages do have attributes. So because they have attributes, we will need to tie the data file to the message so we can load in those attributes. ID, body, and subject. Let's see if we can do auto mapping for this one. There it goes. And then let's just tie together some of these edges as well. Sent message, so that comes from the message ID, is the ID of the message. This is coming from a person to a person. And then the date time, send date, there we go. And then we'll just add one for received message as well. So a lot of this kind of comes down to the data that you have, how that allows you to map everything up and send message to user. So it is definitely important to recognize what format your data is in and sort of how those connections are inherent, or how you can structure your data in a way to make those connections. You can do a lot with TigerGraph, but if there aren't any pre-existing sort of connections within your data, the graph can't, make up anything that doesn't exist. So we'll link these likes, user ID. Oops. So likes, we have a unique ID. We don't need it though, because it's being loaded to an edge. So we can see that by user, liked post at time. There we go. So once again, just like our mapping before, we have to publish this. So we can click Publish Data Mapping. That'll take a few seconds. And then once that is done, we can actually get to the fun and cool part of Graph. I'm aware I'm going a bit over time. Sorry about that. If anyone needs to drop, we do have a pre-recorded version of this whole intro that goes into a little bit more detail. It's about an hour and 15 minutes long, and you can find that on our YouTube page. But if you'd like to stick around, I am more than happy to keep going and give the rest of the run through here. So what I did here was I went over to the load data page and I clicked the play button up here. By default, the play button will load in all of your data. If you only want to load in one file or a specific subset of data, you can select those data pieces and then click the play button, and that will only load in the pieces of data that you've selected. So as these files load in, you'll see in this graph here, this is a graph of the number of edges and vertices in our graph. It's a graph of graphs in a way, and you'll see that that is continuing to climb as these loading jobs wrap up. So this should wrap up with somewhere around 20 some odd thousand edges, and there we go, around 2,400 total vertices. You can get some more information on these loading jobs just by clicking on the file and then clicking between graph statistics and loading file. So you can see some information about that here. We're not going to get a lot on these because in the grand scheme of what TigerGraph can handle, these are absolutely tiny files. It is not uncommon for us to have graphs with tens of millions to billions of vertices or edges in them. So now let's get to the really fun part, which is exploring the graph. So in the Explore Graph tab here, this first page will allow us to search for vertices so we could get a specific vertex by ID. So for example, if we had a person, we know that their ID for this one, their ID is 50. We can do that. And here's person 50. Here's their name and their data and everything. All the data here is completely fake. I generated it through a great website called Makaroo. If you're ever looking to generate fake data, it is great for doing that. I would show you, but every time I go up to my taskbar, the Zoom thing pops up and covers over how I switch tabs. There we go. I hate Zoom, by the way. Makaroo, there you go. This is a great way. You just specify your data fields, their name, the type of data that's in them. They have all sorts of data types that you can pick from. And then you can even specify functions in order to custom generate different types of data through that. But anyway, so back to TigerGraph. We have our node, and hovering over it will give us all of our attribute information. And if you double click on it, that's where it will tie out anything that's related to it. So we can see here all of the messages that this user has sent, all of the posts that they have liked or posted. And if we hover over any of those, once again, we can get some more information about it. And any one of these we can double click on to get the additional information about it as well. As you can guess, as you start to expand out a bunch of these, you can get a little bit crowded. So in the bottom right corner, you have the ability to select different layouts. And if you just select the same layout, the force one again, it'll automatically relay out. But there are a bunch of different layouts here to give you different types of views depending on your data. So you can kind of go through those based on what data you have and see what sort of fits best for what your current selection is. So in addition to being able to select one vertex by its ID, you can select just a random number, random vertices, a certain number of random vertices just by clicking pick vertices here, and you can specify. So if I only wanted people, then I can say pick vertices and it'll give me 5 people. And I'm clearing the graph just by clicking this little eye up here with the slash through it. So that'll just hide anything that's not currently selected, which essentially eliminates it from here. So next down, we kind of have this sub list here. So expand from vertices does exactly that. So if we grab person 50 again and expand from vertices. So I want to see every post that this person has made. If I double click on them, like I said before, it's going to expand out everything that's linked to them. I don't want that. I just want posts. So if I go through here and I click, I just want to know what they've posted. And it's important to note that these are specifies what edges and what vertices it will be able to traverse through. So because I want to see posts, right? If I do this, this will not work. In fact, it won't let me click on it because I've only selected posts. I'm telling it, don't go through any edges, just find a way to get to the posts vertices. That won't work. We need to traverse an edge. So I can select all because I've only selected posts here. So it will only return, it will only traverse edges that end in a post node. So actually, yeah, this is where we spend the thing. Because we can also like posts, we also got what we liked. That's not what I wanted. So let's try that again. So by doing 50, and then here I can deselect this and I just want posted. So expand And there, now we only have posted messages. Additionally, there is pathfinding. Pathfinding is very cool. So say I wanted to find the quickest path between two people. So say person 20 and pick person 50 again. Find path there. Oops, I have to select that again. So there we go. We can see that person 50 posted this post and person 20 liked that post. So this is the shortest path. This will find us things like this, where it is the shortest possible path. But obviously there could be more than one short path. So by doing this, I say, okay, find us any of these. These would technically be a path length of 2, because there are 2 edges. We are traversing a one edge out to the post and then one edge back to the person. So if I wanted to say find some longer edges, I'll set this to 4, and this will find us anything that may have 4 edge traversals in order to get between those 2 people. And due to the nature of this particular graph schema, that is going to give us a lot of results. So this is obviously a mess, but with better structured data, you could get a much better idea of some of your data by looking at this, or even just with this all shortest path things. It's very cool to, just clear that. Very cool to be able to quickly look at your data and see where some of that stuff lines up. So that's pathfinding. And then additionally, we have find connections, which looks for very similar to pathfinding. However, it's between a set of vertices and looking for different areas where they can connect to each other. So we can do that with our previous set, and we'll see that we found two more vertices. We can lay that out. And with anything here, you can drag it around, and this is half the fun of the graph, is sort of playing with your data, so to speak. But there's obviously some cool things you can do there. And then going a little bit further, we can get into queries. So querying, I'm not going to cover in this. It's definitely important, but it's kind of way too much. I'm already over time, and this would be another half an hour just kind of going through queries. But we do have a language called GSQL, which is our TigerGraph query language. I will write it on the fly, just so y'all can laugh at me if it doesn't work first try. But basically, queries are extremely powerful, and they're how you get information out of your graph with everything in TigerGraph. So anytime that you install a query in TigerGraph, that query becomes available as an API endpoint on your TigerGraph server. So if you have an external application, something you want to see the results of that query, I want to see, hey, find me all the posts that person A posted. So I would say I have a vertex. It is of type person. I'm going to call that InPer is our variable name. And then this is one of the quirks of GSQL. I have to define that as a equals, on that as a vertex set. And then from there, I can create a select statement that will select all posts by this person. So I can do select PO from in P. I'll explain this all in a second, because I'm not going to get too depth into this. I just don't want to leave you out in the weeds while I'm writing this stuff up. To HP, and then we want posts. Yeah. And then, oops. So what this will do is we will go from our InPerson. We'll start at our InPerson, who are for the duration of this select statement, we're assigning them a variable of P. So if we ever want to reference that person from within our select statement, we would give them a P. And then this format here of these 2 dashes and the parentheses in between them signifies an edge. In this middle here, you would specify the edge type. So actually, I do want to only find the ones that this person has posted. So I only want to traverse the posted edge. And if I wanted to reference that edge from later on in the query, that would be variable E. I can also just not define a variable. Oh, never mind, I have to. So do have to define a variable. But anyway, you can do that. And then where any of our posts will have this PO variable. So what I'm saying is select PO from our InPerson, and what PO is any post that person has created. So let's go ahead and run this so I can see if I am lying or not. query Vertex InPerson. We'll just have to install it. Install takes a second. This is the fixed. What do you have wrong with my query? This is what I get for trying to do it live. It should work. Shouldn't have an issue with that. Huh. Well, that's a bummer. But you get my point here is that TigerGraph is a very powerful language. It's really not that hard to learn. I don't know why this query isn't letting me do what I want to do. But you can explore our documentation, like sort of how to write queries and how to do all that stuff. And I believe we even have some educational videos if you would like to. That's why I need to do posts equals. There we go. Oh boy, can't type today. And there we are. So now this will work if I save it and run it. So the reason the other one didn't work is because I was trying to return PO, but like I said before, PO is only available within the context of that select statement. So once we hopped out of that select statement, we don't have anything. So I'll type in 50 here like we did before, and these are any of the posts that person 50 posted. And what you'll actually get if you return this as an API call is you'll get this JSON output containing some information about each vertex. So we have our vertex ID, the type, and then these are the attributes of that vertex. So this is a super basic query, but if we wanted to go even further, what we could do, this is really where graph kind of comes in now, is we could do something like, if we wanted to return all hashtags from all posts that this person has made, then we could do that as well by adding in another edge traversal here. I just have to do a little bit rusty with my, so this is version 2 syntax. When you do multi-hops like this, it is a separate syntax, but I'm a little bit rusty with my version 2, so we'll see how this goes. And tag is hashtag, not tag. All right, so now if I save this and we run it, then this will return all of the hashtags linked with person 50. And they don't because I'm still selecting PO when in reality I want to select T. There we go. So now if we run this, we'll actually get the hashtags. Live demos, a lot of fun. There we are. So those are all the hashtags from any post that person, our input person 50 has done. If we change that, we'll see a different collection of hashtags. So this is obviously some very basic examples of some graph queries and some of the graph powers of being able to traverse multiple edges through these posts. But we're missing out on some of the cool things that you could do by then taking, finding multiple people, finding the group of hashtags that they have, comparing those groups of hashtags to each other, and then finding people who post about similar things from that type of stuff. So all of that is very easy to do within Graph, where something like that may be more computationally and definitely more developmentally heavy than just writing a single query. So I know that was a bit over and kind of went through a lot, but I hope that this was a good first intro to kind of Graph, TigerGraph. Hopefully you got an idea of some of the things that this type of database can be useful for. And hopefully I didn't flub this demo too much. So you still kind of hope that it's nice, approachable. TigerGraph is really what we're aiming for through this Graph Studio interface, is the ability for anyone to kind of come in without having to write any code, being able to create your first graph and being able to use that Explore Graph section to really start looking for some cool areas within your data. And obviously, if you want to learn more, we have some fantastic documentation, docs.tigergraph.com. We also have a very active developer community at where is it? What is it called? Developers.tigergraph.com is where you can find a bunch of resources. And then we have a Discord channel as well that is where we do a lot of our help. So I'll just drop some of these in the chat for anyone who is interested. Here's our community forums where you can ask us any questions or anything that you may have. We're always happy to answer and help out. And the Discord is, there we go, right here as well. So I'll just drop a couple links in here really quick. And I hope that everyone is in some way motivated to give TigerGraph or graph databases a shot and sort of play around with them, see if you have any data that you may have your hands on, see if you have any projects that you may have coming up where you think graph might be a good solution for. So that's really all I had. Thank you all for attending. I hope that you enjoyed, and I hope that you look forward to trying out TigerGraph at some point in the future.
Yeah, and thank you. And we'll be sending these videos out and the other information. So thanks again, and we look forward to hopefully seeing you guys at our next event. Thanks.